throughout the session via the chat tool. Time will be allocated at the end for speakers to answer your questions, and use the hashtag NMISOnsites for any questions on Twitter @NMISGroup. Please take some time to complete our survey that will be sent after the webinar. So, introducing the speakers for this morning, we have Mr. Adam Carlos from Beckhoff, Ms. Anastasia Katunj-Steva from NMIS, Mr. Marcos Perez from NMIS, and myself, Mr. Sam Hume from NMIS. Briefly, to provide an overview of the content this morning, I will provide a brief overview of NMIS. We will then be providing an overview of Beckhoff and TwinCAT 3, also of FutureForge and hot edge detection, followed by an introduction to TwinCAT Vision for hot edge detection, and finally, a brief presentation on systems integration with Beckhoff. So what is the National Manufacturing Institute for Scotland? The National Manufacturing Institute for Scotland is a group of industry-led manufacturing research and development facilities where research, industry, and the public sector work together to transform skills, productivity, and innovation to attract investment and make Scotland a global leader in advanced manufacturing. NMIS will increase productivity by reducing barriers to innovation. It will stimulate investment and increase manufacturing competitiveness. It will catalyze job creation and strengthen supply chain links. It will inspire and attract talent and equip current and future workforces with the skills they and businesses need. And NMIS will work with manufacturing businesses of all sizes in multiple sectors, providing benefits across the whole of Scotland. NMIS is part of a One Scotland team. We are operated by the University of Strathclyde, and we are supported by the Scottish Government, Scottish Enterprise, Highlands and Islands Enterprise, the High Value Manufacturing Catapult, Skills Development Scotland, Renfrewshire Council, and the Scottish Funding Council. Finally, we have an infographic here describing the organisational structure of the Manufacturing Institute for Scotland, demonstrating the core elements of NMIS. In purple, we have the outreach activity, which we're currently undertaking. In the yellow, we have the 2 specialist centres which are currently open, the Advanced Forming Research Centre and the Lightweight Manufacturing Centre. In the pistachio and teal, we have core elements which we will be introducing and opening in 2021. We have the Digital Factory, Collaboration Hub, and Manufacturing Skills Academy, which will all be housed in one location, which is opening from 2021. And without further ado, please allow me to introduce our first speaker, Mr. Adam Carlos from Beckhoff.
All right, thank you, Sam. Good morning, everybody. I'll just give my screen share a few seconds to get up there. And that looks good. Right, yeah, thank you very much for joining us. My name is Adam Carlos, and I work for Beckhoff Automation. And I thought a good place to start would just be a quick introduction as to who is Beckhoff Automation. So when we go through our presentation this morning, you have an idea of who we are as a company and what we're bringing to the market. We are a German family-owned company. We supply hardware and software solutions to the automation industry. We do all of our manufacturing in-house in Germany in a town called Fell, and we've been running for about the last 40 years. And we can be considered the pioneers of PC-based control. We've had amazing growth over the last 40 years. And as we're family-owned, our managing director, Hans Beckhoff, puts a lot of his effort and energies back into R&D. So we've been responsible for a lot of technological advancements in the automation industry as well. Some of you may know EtherCAT. This is one of our big kind of wins in the automation technology. This is currently the fastest field bus system currently being used in the automation industry. We have about just over 4,000 employees, and 40% of these are actual engineers. So whether that be on the application level or support or R&D, we have a large kind of, well, 40% of us are engineers. So it is a very technically based company. We have around 75 subsidiaries and distributors around the world. So we have a good global footprint, which allows us to support our product globally as well. And if we're able, under the current circumstances, we should be hitting the €1 billion mark soon as well, which puts us as a very strong contender in the automation field, with a lot of companies vying for the for top spot as an automation supplier. So what do we actually do? What do we actually bring to the industry? So we, being pioneers in PC-based control, we supply industrial PCs to the market. We have a range of I/O. We have a large range of motion control, so servers, stepos, our extended transport system, which you can see in the image there, and then our automation company as well. So these four aspects are a quick way of breaking down the large amount of product that we have. I could go through all of them, but that would take a lot more than the 10-15 minutes that I need to get through them. But essentially, the PC on our side is the controller. This is complemented by the I/O system, which has a large range. It's plus minus about 500 different signal types, ranging from safety to standard digital ins and outputs, ELX terminals, high frequency terminals, field bus connections, things like that allow the end user or system integrator the flexibility to build a really complex system, regardless of the industry that they're running in. And the motion side of that as well is then brought into that same system over EtherCAT as well. So it lets you build up this infrastructure. And the automation side of it, the software, ties all that together, allowing the engineer a single platform to work from, knitting all of this hardware and software together. That's not to say that you always have to use it together. Individually, these products are standalone. So if you are looking at just industrial PCs for a particular project, that can be used outside of the scope of using it with our automation or our I/O. So it's individually, they are powerhouses in themselves, but knitted together, they give us this real-time system that allows our engineers a single toolbox to work from to build their system up entirely. And what we'll go into later on today is how we've added vision into this automation side of things to grow our system even further and offer more in the automation toolbox. This allows us, this flexibility and this range of products allows us to work in a multiple different types of applications and solutions and industries. So whether that be in warehouse and distribution, we'll be able to do the complete control. So moving part A to part B, and track and trace flexibility. So being able to not just control where things are going, also know where they're going, and integrating vision into that system as well allows us to have this track and trace and being able to pass information up to, whether it's a cloud system or whether it's to local storage. It's easy to develop these systems regardless of if it's a machine or if it's in a warehouse. It gives the users that flexibility. So packaging, window production, printing, it's a large range of fields that this software and hardware can be split up to do different tasks. Process industries as well, we have specific range of hardware and software that can go into these environments. So for example, ELX terminals, which are explosion proof. So allowing us to kind of specifically have units that can go into these industries is key for us. So that's a little bit about what we actually supply, but what have we been doing with NMIS over the last couple of years? We have been Tier 2 members. This started with the specialist group under NMIS AFRC, and we've been running with them for a while now. And we like to get really involved with what they're doing. It's a great team there, and we've been supplying them hardware and our software solutions so that we can kind of target the particular things that they're working with. We provide them with engineering consulting and support, and that can range from a general meeting of general discussion of what they're doing to actually getting involved in doing some programming and being really heavily involved with what their kind of vision is to get this project complete. And that's exactly what we're doing on the hot edge side with them with the integrated vision. We're actively involved in their open days, and we provide training to them as well. So we've had guys over to our center to kind of educate them and get them up to scratch on what TwinCAT can do for them within their environment. And that lets them kind of take these bits and pieces and build it onto what they're doing. And then that brings us to the vision part of it. So with a little bit of background about what Beckhoff provide to the market, we provide hardware and solutions. And one of these solutions that we've now added is TwinCAT Vision. So this allows our users to take the existing bits that they've been using and add the functionality of vision to that. So it's allowing our users to say, I've got this system, I'd like to connect directly to a camera. So you can pull in image acquisition directly into this real-time environment that Beckhoff supplies. And that whether that's for general kind of inspection, for track and trace, if your object detection, which is kind of what we're doing here, if it's looking at barcodes, things like that. But depending on how you need it to work on your machine, you can pick and choose from the different sets that are available within the TwinCAT Vision kind of realm that we've added to this automation scope. And then that allows us to kind of say, well, we've got this entire, so if I look at this as a system, as an example, here we have multiple stations and we need to integrate our platform into that. So providing IPCs for the visual and the control side of the machine, providing our motion to go into the machine and have that connection across the board to our I/O systems and bringing everything to a single platform. Now being able to now introduce vision directly connected to this same kind of control structure gives us this real-time control. So we're removing the need for a kind of a third-party vision aspect. We get to bring this in and we get to simplify I suppose, the process of getting this machine up to scratch. And then from that side of it as well, going more into this kind of 4.0 industry and being able to provide information to the cloud based on whether that be predictive maintenance information, or if you're looking at your track and trace or kind of product defects, what is the efficiency of the machine, all of this information from that control system and these individual components that make up the system have this one platform that make it easy to pass this info to a central location. So every little bit of this machine can be considered an individual piece that can be knitted together with the Beckhoff platform. And that's really what we're looking to do in manufacturing and automation in general, is make things simpler so that when we're talking about smart machines and Industry 4.0, the easy part is getting the machine running, and the next stage is having information so that it can be passed to analytics teams to start working out how can we make these machines faster and how can we make them better, and having a real-time system that passes that info up is obviously a key factor there. So that's us in general. I'm going to hand over to Marcus now, and he's going to go through a bit of FutureForge and the hot edge detection in detail, and then I'll be able to come back and explain how we did that with the Beckhoff environment. Marcus.
Okay, Adam, thank you very much. I would like to introduce myself. My name is Marcos Perez. I work in Advanced Forming Research Center, which is part of the National Manufacturing Institute. Right now, I am working coordinating aspect of activity related with FutureForge. So before making an introduction about how to integrate this kind of visual system developed by Beckhoff into industry or manufacturing processes, I would like to take the opportunity to make an introduction about what is FutureForge. So FutureForge is an ambition program that we are right now working at the AFRC. It's around £20 million investment. We're trying to develop and to integrate a new unique hydraulic press, which is a 3-modal 2,000 tons press, which is unique because can integrate 3 systems into one single press, which can operate under open die forging, closed die forging, and also isothermal die forging. Apart from this press, we are also working in the commission and installation of electric or gas furnace, and also the manipulator. So as you can see in the screen, it's just a digital representation of FutureForge, how will be in a few months. So basically, these facilities is expected to be ready for business for February the next year. So and right now we are working in a set of capabilities development to integrate new technologies into FutureForge. And also this platform is the main aim of this platform is to provide a cost-effective accelerated validation capability for industry, and also for high integrity forge component for aerospace, for industry, for oil and gas and nuclear, so for a large range of industry. So initially, this project or this program was funded by the Aerospace Technology Institute, ATI, in UK, by the Scottish Enterprise, and also with internal catapult funding from the AFRC. And also, as I said, this new program will bring a unique capabilities to the FRC and also to Scotland and to UK in terms of open die, closed die, and isothermal forging. So in the next slide, I will make a very brief introduction how these technologies in terms of beacon system or vision recognition could be implemented into the industry and also in the forging industry, which could bring significant or very important capabilities. For example, and you can see in the screen, there are forging process, open die forging, the cogging process, which is the conversion from cast ingot to billet, forging large components, and also forging large components with different shapes. So the main characteristic of this forging process are they are very complex because it requires a lot of passes of deformation on blobs with a lot of reheating. So to have the opportunity or to have a tool which allows us to automatically collect information about the shape, to monitor the shape change during the process, will give us a lot of opportunities to improve and to develop understanding about the process, about how the material behaves, how to improve the process, and also how to implement and develop new solutions for the new world. So this is just a very brief introduction about how the benefit of hot edge detection by means of this vision system, just to understand what is the shape change during the forging operation. And in the next slide, I will describe basically what are the benefits of this solution to be integrated into manufacturing process, especially in the forging industry in particular. So this kind of automatic system, which can provide a reliable and automatic geometry measurement in a question of a few milliseconds, could give us a lot of opportunities to understand what is geometry evolution during the forging processes, and also to develop a better understanding and to provide a better description about the process and also the material response, and also how to integrate with, and also the solution will allow us to integrate this kind of monitoring system into industrial processes, which sometimes is quite challenging. So this kind of very quick response in the automatic measurement and analysis of the image by this vision system will give us a lot of opportunities, as I said before, and also will give us to develop very accurate process modeling and to fit into potentially microstructural model to understand what is the microstructure evolution, and therefore to predict what the final properties will be. So this is a huge benefit, could be developed by means of this system. And also this automatic data collection, which allow us to easily to implement, to develop Industry 4.0 solution in the future, like to apply artificial intelligence, big data, and also to develop digital twin for manufacturing processes. So just very excited, looking forward what we can achieve between this collaboration between Beckhoff and AFRC. So thank you very much. I will pass to you the control, Adam.
Great, thanks, Marcus. Okay, so I'm going to then jump back into where we're at with this press at the AFRC, because we had a bit of existing infrastructure that we've been working with them. And it's a good kind of, just to give you a background of what we have and how it's been easy to add the vision application into what is existing. So we have what you can see here is a press and a control panel. It's a rather old press, so we would consider this legacy, and this has an existing control system. So what we've been tasked to do, and what we have done and is now up and running, is obtain the the actual press control information. That is all it's doing right now is controlling this press. There's no physical monitoring. We've relied on a Modbus TCP connection to obtain that information up into our Beckhoff IPC, which we've called the data collector, because essentially that is what it is doing. And as well as that, now, because we've got the real-time platform and the ability to have high speed data collection from the field, we've added these as external and additional to the actual values we're getting from the control system. So we can do some mains monitoring, we've got some simple vibration set up, and we've got some ambient temperature measurements. And this is things that we've added that we thought might, okay, well, let's see if these are going to be interesting and if they'll have an effect on the process. Because until you've actually done this and got this data and you've analyzed it, you're not sure if you quite need it yet or if it is critical. So obviously the press information is critical from the control side, but how is vibration and temperature and mains having an effect on these type of things? So we picked these as items to start with. So this system as it is exists and is currently collecting information from the press, and we're presenting that onto a dashboard system and recording this values live. So the members of the AFRC can analyze those and compare them to their press kind of results. Right, so, and I gave you that little background to see how we've now been able to add vision to that system. So the next task obviously is that the real core of this is the billet being pressed. And what we've got here is a sample image of what that would look like inside the press. And we've then taken one of our small footprints C6015, which is a very compact quad-core atom processor. So this is an extremely powerful unit packed into a small footprint. It's fanless, and it can simply be put somewhere nice and kind of compact next to the existing infrastructure. And because the Beckhoff environment allows us to communicate across platforms very simply on a single kind of variable database, getting information from the system up to the data concentrator becomes a very kind of simple task. It's as easy as connecting it and saying, yes, I want this information up here. Thank you very much. So what TwinCAT Vision being added to the platform has given us is the ability to take existing IPCs that we have and connect them directly to any GIGI-enabled camera. So that direct connection into the camera allows us to get rid of any kind of middleman IPC that might be needed to do the image acquisition. That image data is passed directly into our automation interface. The same interface we used to program the press now has image data within that. And we can start to use the vision algorithms that we've added to our platform to analyze this billet. At the moment, we're working on images and sample images to kind of fine-tune this process. And the idea then is to connect directly to a camera. We're looking at some near-infrared so that we can start to wash out any of the other kind of lights that may be coming through and get a real clear image. And that will allow us to get the best kind of image result into the Vision PC to perform our testing on that and get these edges as clear as possible and make accurate measurements. Right, so let me go to the next one. So moving away from the hardware, so the hardware setup is essentially all it is our PC with the TwinCAT 3 Vision supplement connected to a camera, taking care of obviously the lenses and lighting. We want to make it as flexible as possible. But everything that we can correct in light, that will be done on the camera side. And then once we've got this ideal image, we'll pass that back to the TwinCAT Vision environment. I've got some images there. So that's essentially what we're looking at in general. We want to get our images into the PLC environment, and then we want to be able to pass that image to a nice kind of user interface that can be accessed by the AFRC team, or anyone that would like to give access to collect this information as it's being processed. So going a bit more into detail on what it looks like. So on the right-hand side there, you can clearly see this is our billet that is being looked at in the near infrared. We've got a filter on at the moment, and that gives us this image. And then you can see some other kind of lines and bits and pieces, and obviously the vision experts out there will know exactly what that is, but I'll go through them in a bit more detail. So what we're doing on the actual billet is we are looking for edges. So we have a defined function block that we can call into our program and say, right, I would like you to look for this edge. At the moment, we're looking for left, right, and top. And the red boxes that you can see there are a defined recipe box, region of interest, if you like. So we've put these in so that we can increase the amount of process time, because obviously there might be different size billets from the offset. So the users can define a recipe that will say, right, the billet initially is going to be this size. So we can narrow down these regions of interest so that our process time can be brought down. And then what that lets us do is our locate edges can work within those confines. We're working on subpixel accuracy as well. So we're really able to drill down and get a fine point so that we can stay within the, the accuracy that the AFRC is requiring to do these tests. And the more accurate it is, the better their results will be on the data side. And then they're kind of what Marcus was going through. They get to make better judgment calls on how it's being changed. We've got some other simple blocks that we're using as well to try, and we're obtaining kind of the general mass so that we can get some centers so that we can start doing some more accurate measurements. And at the top of the image there, you'll see our process time. So what we're able to actually do because of this TwinCAT environment and the way the platform is designed, we can see exactly how long each of these processes are taking. At the moment, 3-edge detection with a kind of this set area, we're able to do that in quite a high speed, and being able to change that speed is critical as well. So a bit more on what it looks like on the actual coding side, and I hope you can kind of see that. But this is the TwinCAT environment. So when I've been talking about automation that we supply, this is essentially TwinCAT 3, and this is where everything gets done. So the existing system at the moment, our condition monitoring lives inside this area. Our vision is inside here. Our HMI development is in here, and we have that single platform, that single variable base that we're working with, and we're able to intertwine the code of image inspection with condition monitoring. So I could pinpoint at a particular time, I could say, well, I'm reading the vibration at this, and I've noticed that something's happened on the edge. So you can start really matching these data types up together on a single timestamp and pass those up to wherever this data is being stored. And that's kind of the choice of the user. Where do you want it to go? Which is also essentially managed from the same platform. So being able to program it in this single environment is key. So there you can see we've got the HMI interface, and this is just highlighting one of the locate edge functions that we've dropped into the structured text code here. So essentially you get a state machine for the camera, and you build up what you want within the code environment. So if you want, say, 4 separate locate edge functions, I can drop those in, and I can monitor those and say, right, you're looking for this and this and this. I have individual access to each of their parameters, which I can then give that to myself in the HMI, and the users at the AFRC and NMIS can kind of start building what they want from the system without changing the core functionality of the code, which already exists. And that, like I said, that complete solution explorer allows us to do everything. So I'm doing my vision, my PLC, if I have any motion control, this all lives inside that same environment. Additional functionality as well. Obviously, not everything is going to be catered to with a set library. You try and cover as much as possible. And there's a large range of algorithms and functions that come with the vision inspection library. But obviously, you don't have vision inspection without any kind of math functionality. And this already exists in the PLC. So we're not reinventing this. This is a simple piece of code that we've used here to measure distance between coordinates and give us a heading as well. So we can counteract for any kind of rotation, because this camera might need to be positioned somewhere else. So if we move this across, we might get an angle on the billet. This block that we've developed allows us to find that angle and counteract that when we're doing any kind of precise measurement. So it doesn't take that into account. Obviously, if there's not enough mathematical functionality in the standard blocks, then you can move this into other systems like MATLAB, Simulink, these type of platforms that you will find in places like AFRC and NMIS that they're using already. So being able to pass information, perhaps store the data and say, right, we've done as much as we can here. Let's have a look at it in another math program so we can kind of start really getting into the nitty-gritty of what we've found from these edges. And then at the end of it all, really what we want is a really nice interface, somewhere that is easy for other engineers who onboard into NMIS or AFRC and can basically say, right, this is what we've developed, it's working, now you can have the input here. So we'll give them edge detection parameters. Obviously, we've made it a bit nicer with a nice kind of HMI so they can see exactly what they're looking at. And it just gives them this working environment. And this is all developed, again, within that same platform. HTML or JavaScript can be used to make it a bit more extraordinary, so you can start building up your own kind of tools for that. And then this can be viewed in any kind of browser. So the nice thing is here, if you think back to how I was saying, we've got this kind of overall topology. Users from out the whole AFRC can jump onto this wherever they are. We've added things like a quick CSV creator. So all of those edges can be easily just mapped onto a CSV. You can select your file location over there, as you can see, and you can put it onto wherever it needs to go, essentially. Because when you've got multiple engineers or multiple kind of people doing R&D on something like this, giving them access to this information is key. You don't just want it stored away and not used. You need it to be made available. And again, that's where having a single platform like TwinCAT allows us to take all of these things into account. And if we need them, it's easy enough to add them. So what that kind of looks like as an overall view, essentially, I'm looking at this now. I've showed you the kind of overview of what it looks like as the press in the real world, but what we're looking at in terms of a general IT infrastructure, because we need to integrate that into these platforms. Big buildings that are being created and made and exist, you're going to have a server room, and this is obviously where everyone is tied into. So we need to find a good way to make this information available to everyone. So Modbus TCP collecting legacy data, obviously all of our additional information that we're collecting. We have a single dashboard that they can all work from, and all this information then can be sent to a central server. And that allows these users to jump onto that HMI that I just showed you and collect this information easily and quickly. And then looking at that system there, this is where we've been able to just quickly add the vision system. So connecting that up and saying, right, we've got our vision system, we can tap it into the existing system, and all of that image data, that CSV file, or whatever platform we want to access it via, we can grab that through this standard Ethernet TCP IP connectivity. And we can go as far as then saying, right, I want these systems, that actual data concentrator, to pass information to Microsoft Azure or SAP HANA or any of these larger kind of cloud-based storage platforms as well. So it's the benefit of Vision being added to Beckhoff allows us to now tie this all into a single platform. And we're already doing this. I mean, this is a connectivity that has existed for a while, but adding smart systems like TwinCAT 3 Vision into this platform allows the existing infrastructure to make use of these new technologies, and being able to give that to the AFRC and say, right, well, yeah, this is how you're going to be able to get this information easily, especially when it's something as complex as hot edge detection. You don't want that data to go to waste. You want it to get to a usable location. And that is me at the end of my bit. I'm going to hand over to Anna now and let her go into a bit more about the system integration.
Hello, everybody. My name is Anastasia. I'm a digital manufacturing engineer for NMIS. Thank you, Adam, for your slides. So this is the last section of this webinar where I would like to talk about systems integration for manufacturing. And we'll show you an example of a successful integration project we've delivered using the TwinCAT 3 environment. So what is integration and why it is so important? Integration in general means bringing together different subsystems into one system in order to enhance management efficiency and improve productivity. Systems integration in manufacturing, apart from machines communication, also provides centralized data acquisition capability, which enables data-driven decision-making and supports innovation. So, why is integration important? All data from various sources is securely stored in one place. There is no need to collect data separately from every system. Unified timestamp for all integrated systems. This is crucial for systems where process parameters are changing, for example, every 1 millisecond. Even a slight difference in time settings here can lead to wrong interpretation of results. Efficient data analysis, where all data is stored in one source and timing is synchronized. It allows proper data analysis, as it's far easier to determine correlation between different events. So your database can be interrogated quickly, and once you have the initial architecture set up, it's easier to integrate new data sources in future. All data can be visualized on one dashboard, which is very convenient for user and can be accessed remotely. Data is visualized on HMI in real time in a convenient form. No need to deal with CSV files and post-processing of raw data. All these benefits provide opportunity for manufacturing growth and innovation as you can understand your system better. Okay, let me show you how we integrated systems in our workshop using TwinCAT environment. So this was undertaken on a small-scale project to demonstrate the benefits of integration. Please note that this is not FutureForge, this is a much smaller system. Adam has already mentioned that as part of that project, we connected the 500-ton press, but there is more to it. You can see on the slide some of the systems we are using during forging trials. Before integration, we had around 6 standalone systems, including the hot edge detection. All of those systems had its own timestamp, data acquisition system. We needed to use a dedicated laptop in order to run specialized software to support their operation. So there was no real-time data visualization for some of the systems, and we had to deal with post-process data analysis, which is not efficient, and as you can imagine, it doesn't add any value to the process that has already been finished. So integration of these systems allowed us to get rid of extra reading devices, laptops, specialized data acquisition software that significantly simplified and optimized the architecture of the system. You can see the difference on this slide. So now we have access to real-time data and can see everything we need on one dashboard. Data is synchronized and stored in one place. Engineers and managers can safely access dashboards remotely. And of course, more devices can be added at any time. This case study shows how significantly system architecture can be simplified and optimized through integration. This optimization enhances research and development activities targeted at quality improvement, as it allows precise analysis of the processes and deep understanding of correlation between different events. So why we decided to work in TwinCAT environment and what is special about it? You probably noticed how different the integrated systems were, from simple thermocouples to custom-built machinery with complicated PLCs full of data. And of course, our unique hot edge detection vision system. Initially, integration of hot edge detection was the most challenging task, as the image processing technique here is very unique. Our senior manufacturing engineer, Alistair McDonagh, created a specific code in MATLAB to process images and generate graphs outlining the dimension of forged parts. So in addition to integration, we wanted to reduce latency, and we needed a solution that would allow us to see the results in real time on the same HMI dashboard. So addition of TwinCAT Vision into the environment allowed us to have this integrated image processing solution that solved the challenges we had. I'm sure that Adam already mentioned that camera configuration, all programming tasks, and HMI dashboarding can be carried out in the same PLC environment, which is extremely convenient for the user. So moreover, with TwinCAT Vision, image processing tasks can be integrated into the central control system that lays a strong foundation for development of advanced closed-loop control systems. Of course, this is an ambitious goal, but that's why the National Manufacturing Institute Scotland is here to solve complex manufacturing challenges. To finish off the presentation, I would like to thank our member Beckhoff for their dedication and continuous support on that project. And finally, from all of Beckhoff and National Manufacturing Institute Scotland, thank you very much for your attention, and we will now happily answer all the questions that you might have. Thank you.
Thank you, Anastasia, and thank you, Adam, and thank you, Marcos, for your respective presentations. They were most interesting, and I'm sure that the audience found them just as interesting and as engaging as I did. Throughout your presentations, you will have noted that we've received a few questions. So if I might, and I'd like to address these to all of the panel. The first one is from a Matthew Limmer. Do you have any case studies or examples on how TwinCAT 3 can be used in FMCG industry?
Are we talking about fast-moving goods? Is that I assume that's what we're
I assume so, yes.
So yes, we do. We have quite a few. I mean, we're heavily involved in that side of things. We have a lot of manufacturers or machine builders who are involved in that. It's the kind of thing that I could get in touch with you directly and show you some kind of examples of what we do. Specifically ones off the top of my head right now, I'd rather think about it and then say, right, these are the ones that I can show you and you can have a look. We have general ones on our website that I can forward on to you. So if I'm able to get, is it Matthew?
Yes, indeed, Matthew.
Hey, Matthew, if you want to drop your email address there and we can get your details, I'll be more than happy to send you through some very detailed examples of how TwinCAT 3 is involved in that industry and the particular products that we supply to those machine builders that then pass that on and design these machines that complement that industry. So yes.
Thank you very much, Adam. I should also note to the audience, on the screen at the moment, you will see a list of email addresses for inquiries, so please do not hesitate to contact us. I have a second question here, which came from Thomas, which is, how do you centrally control your timestamp?
How much time do you have, Thomas? Well, look, it depends. There's a lot of different ways, and it depends on how accurate you want this to be. Everyone wants it to be as accurate as possible. At the moment, we synchronize the time between the two systems. So we can either use the Windows time, or I can basically look at my CPU clock, and I can take that and I can match those against each other. The most important thing is that if we needed to have synchronized, really high synchronized time, we have distributed clocks and systems like that we could implement. At this stage, we're looking at the time of the PC, and we're taking that and stamping it at exactly the same time and then cross-referencing those. So there's a few ways to do it. How we're doing it at the moment is making sure we take the values from the same system at exactly the same time and stamp it as we collect that data. So at the moment, it's not at the end result of what we would be doing in terms of highly synchronized information. But yeah, at the moment, we're just using the timestamp from the actual unit and then making sure as we collect information, we stamp it at that exact point. But we could go into that question a lot, but yeah, I think I can leave it at that. Yeah.
In respect of time restraints, perhaps we should move on. But thank you, Adam. And again, I assume that that Thomas can contact you directly.
100%, yes.
Thank you. I have a question here, which is actually from myself, and this would be directed at yourself, Marcos, if you don't mind. Can a company become involved in the FutureForge program?
Well, initially, the FutureForge program is basically the design and installation of the new facilities. Obviously, the involvement of the companies is mostly how to make use of these facilities for their own businesses. Obviously, if a company is interested just to engage and to understand what are the possibilities of collaboration on how this facility could be used, or what is the know-how they can provide as well, just to be integrated, because this is a research platform, just to integrate new technologies. So we are more than happy to have a discussion, and if somebody is interested to have a separate discussion about FutureForge, so feel free just to drop me an email, as you can see in the screen.
Thank you very much, Marcos. Thank you. Finally, we have another question here, which has just popped up. Can you automate, and forgive me, this has come from Michael Bodie, can you automate image capture or process from a video in line with forging for the hot edge detection?
I'll grab that. Yes, I would say essentially there's a lot of variables and a lot of aspects to that. Ideally, how we're doing it now is with a still image. We take a snap, then we process, then we get the next image. But it would depend on how quickly you could update that constant feed. But essentially, if you had a camera that could provide you with that image on the fly, essentially a video as you're watching it, yeah, you could. Gigi-enabled camera from one of our units, connect directly to that. I've actually done some playing around with that, and you could, but it would be a question of how quickly you want to get that information back. Essentially, this is leading into how we want this to go. We want to be able to close the control loop. So at the moment, this is all about monitoring and processing after the fact. But what you're getting at, and what you might be what your point might be, is that you want to be able to close the control loop. So as you're watching that being kind of compressed and looking for any kind of anything going out the side, you want to be able to change the control process based on what you're viewing. So yeah, that's kind of where we want it to go. And you can have a live stream from a camera that you are constantly monitoring. You just got to make sure you have the CPU behind it to do this, which essentially is the conversation we would have in the beginning, is saying, right, what CPU do you need to constantly monitor a live feed? Not taking into account it has to be this particular camera with this enabled connectivity, etc. But yeah.
Thank you very much, Adam. Thank you. And just so that we're not picking on you all the time, Adam, I have one question here, which has come in from a representative of Scottish Enterprise. And I believe this one's aimed at yourself, Anastasia. Are NMIS activities around system integration focused on efficiency or cost reduction?
Yeah, thank you very much for your question. I guess it's both, because integration can provide a lot of benefits to any process. So you will understand your system better. You will be able to control your systems better. So it provides opportunity for proper data analysis. And, yeah, so I guess it's definitely both.
Thank you. Thank you very much. Well, that's all of the questions that we've elicited from the chat function this afternoon. So please, if you can think of any other questions that you have, any other inquiries, please do contact us on the emails address provided here. All that remains is for me to thank our speakers. So Adam, Anastasia, and Marcos, thank you kindly. Thank you kindly to the audience members for your participation. And thank you for the marketing team for having arranged the Insights event. So all that remains is for me to say thank you very much, and we look forward to receiving your inquiries and seeing you at the next event. Thank you.
Great. Thank you very much.
Thank you.
Thank you very much, guys.
Thanks, everybody. Just to say, I will be just ending the session now. But before we go, I'll let you know that next week we have another in our NMIS Insights webinar series. So if you're interested, it's on digital twinning and manufacturing, improving productivity and efficiency, and reducing waste. And that is on Thursday, the 18th of June, at the usual time, 11:30. So if you're interested in signing up for that, there's still spaces, and you can find more information on the nms.scot website. Okay, thank you very much, everybody, and a survey will follow shortly. I'll just end the session now. Thank you.